Okay, so question 1. So if we have a look at this, each year Wenford Hospital records how long patients wait to be treated in the accident emergency department. So we got 2015, they waited 11% less time than in 2014. In 2015, the average time patients waited was 68 minutes. So if we just underline that, so in 2015 the average wait was 68 minutes. It said they waited 11% less time in 2014. So what I'm going to do is I'm going to write 2015, write 68 minutes, and 2014 just above it. Now, if they waited 11% less in 2015, we don't know what this is, but it must have been higher. So we know our answer should be higher than 68 minutes. So we should know that a total percent is out of 100, so 100%. So usually it would represent 100%, but this is now 11% less. So what that means is this 68 minutes, it now represents 11% less, so it actually represents 89%. So what we can do is we can use our calculator to find out what 1% is. So if we divide 68 by 89, we get 0.76 ... Okay, and we're going to use the answer function in our calculator. So we need to make 100% to kind of find the original value. So if we times using the answer function on our calculator, answer times 100, that gives us 76.4044, etc. Now the question here says give your answer to the nearest minute. Well, this here would be the nearest minute. If we look to the right, that's a 4. So our answer is 76. Well, it's got minutes there, so 76 minutes. Okay, so part B. The hospital had a target to reduce the average time to patients to wait to be treated in the accident emergency department to 60 minutes in 2016. Work out the percentage decrease from 68 minutes to 60 minutes. So we've got 2014 now. If we just conclude this, we've got 2014 at 76 minutes. We've got 2015 with 68 minutes. And now this target of 2016 at 60 minutes. So we need to find out the percentage decrease. So in order to do that, I'm going to recall the following formula. So the percentage change is equal to the difference over the original. So we don't have to do any rearranging because the percentage change is what we're trying to find out. So what we can do is fill that in. So I can just put percentage change equals the difference. Now the difference between 68 and 60, so if we just write this out, 68 take away 60 over the original. Now in this case the original is 68 because that's the previous year. So if we type that into our calculator and then times that by 100, we get 11.7647 ... and if we work it into the nearest percentage, we'll get, or to one decimal place, 11.8%. So in 2015, if that's 68 minutes, if it drops 11.8%, it will give us 60 minutes. So what we can do is we can check this. Okay. Let's say we've got 68 minutes, which is what we've got in 2015. If we drop this by 11.8%, if our answer is correct, we should get around, because we've rounded, we should get around 60 minutes. Okay, so let's try that. So we do 100 take away 11.8, that gives us 88.2. So if we do 88.2 divided by 100 and then times that by 68, it gives us an answer of 59.976. So close enough to the 60 minutes, so we know we got that answer correct. Question 2. There are only red pens and blue pens in the box. There are 12 red pens in the box. The probability of taking at random a blue pen from the box is 2/3. Work out the total number of pens in the box. So if I write red and blue. Now it says there are 12 red pens, and we do not know how many pens, how many blue pens there are. Now it says the probability of taking at random a blue pen from the box is 2/3. So the probability of this would be 2/3. Well, probability would be out of 100% or 1, but if we also look at this fraction, that means there's a 2 in 3 chance that you could get a blue, which must mean that there is a 1 in 3 chance you could select a red. Now we can see here that 1/3 represents 12 pens. So if 1/3 represents 12 pens, that means that 2/3 represents 24 pens, because 12 times 2. We need to find out the total, so we just need to add these two together. So 12 plus 24 will give us 36 pens. Okay, question 3. Make t the subject of 5t minus g equals 2t plus 7. So we've got a t here and a t here. So what we're going to need to do is we're going to need to multiply out the brackets. So we'll have 5t minus 5g equals 2t plus 7. Now let's move the t's to the left hand side. So obviously the 5t can stay there, and we need to move across the 2t. 2t at the moment being positive, we have to do the inverse, so let's take away 2t from both sides. That leaves us with 3t minus 5g equals 7. Now, however tempting it is, just do one thing at a time. So now I've got the t on the left hand side. I need to get rid of this negative 5g, or the inverse or the opposite of negative 5g will be to add 5g. So if I add 5g to both sides and write that up here, I'm going to get 3t equals 7 plus 5g. And now the question does say it needs t the subject, and that means that the end answer should be t equals. Okay, now at the moment we've got 3t, which is not what we want. We need to get rid of that 3. 3t together means 3 times t. So to get rid of that, we need to do the inverse of times, which is to divide by 3. And therefore we have t equals 7 plus 5g over 3. And this is our final answer. Right, Henry is thinking about having a water meter. There are 2 ways he can pay for the water he uses. So you can use the water meter here with some different charges, or no water meter, and he gets a flat charge of £107 a year. So we need to work out which is cheapest. So we've got here initial charge of £28.20 per year, regardless of how much water is used. Then it says here 91.22p for every cubic meter of water used. Now some of you looking at that straight away may think it's just a pound sign there, but that's actually 91.22 pennies for every cubic meter of water used, not £91.22p. So just be careful. So looking at this, it says here the 91.22p, and then it also says in bold 1 cubic meter equals 1,000 litres. It then follows on to say that Henry uses an average of 180 litres of water each day. Henry wants to pay as little as possible for the water he uses. Should he have a water meter? So what I'm going to recommend doing first is converting the 180 litres to cubic meters. So if we write here 180 litres per day, what I want to do is get that into cubic meters per day. So if I write 1 cubic meter equals 1000 litres. Now I want to get this to 1 litre, so I need to do 1, and how do I get from 1000 to 1? Well, I divide by 1000, so I need to do that on the left hand side, so I'm just going to stick with a fraction for now, so 1 over 1000 meter cubed. Now I know that Henry uses 180 litres, okay, and the same thing here. How do I get from 1 to 180? I times by 180, so I'm going to do the same here, times by 180. So if I do that times by 180, I get 0.18 meter cubed. So from this I can say that 0.18 meter cubed is used per day. It's always good to lay your work out nice and neat, and trying to put as much as you can so that A, you don't lose track of what you're doing, and B, for the examiner. So 0.18 meter cubed per day. Now it says here that he gets charged 91.22p. So what I would like to do is find out how much he uses in a year. So what I'm going to do is just write year like this, then do 0.18 times 365 days, which will give me 65.7 okay of water, cubic meters of water used in a year. So if that's what he uses in a year, I've then got to do the cost, or part of the cost, so that will be 65.7 times, and this is the bit where you need to be careful of, this is 91.22p, so think of it, for example, as 91.5 pence. It's not £91.22p. So if we put the pound sign here, it's actually going to be 0.9122. So if you do that, 65.7 times 0.9122, you should get a total cost of 59.93154. Okay, now let's not forget the flat charge of £28.20 per year, so then we need to add that. You can also write flat charge there if it helps. Okay, so if we then add that to it, we get a cost of £88.13. So obviously looking at that, a water meter will cost him £88.13. With no water meter, it will be £107. So it obviously makes sense to go with the water meter. Here are the marks that James scored in 11 maths tests. Find the interquartile range of these marks. So before we start with the numbers, we need to remember the interquartile range. So it's the quarters, isn't it? So it's the lower quartile and the upper quartile. Okay, and the range is when you do the upper quartile, take away the lower quartile. Okay, so it's the same as range with data, except we're talking about the interquartile range. So it means instead of involving the highest and the lowest number, it's involving the upper quartile and the lower quartile. So the lower quartile would be 1/4 of the data, and the upper quartile would be 3/4 of the data. Okay, so what I'm going to do quickly is just rearrange this in ascending order. So we're going to start off with 11, cross that off, 12, cross that off, 13 and 13, cross these two off, 16, we've got 2 17s, 1 18, 2 19s, and 1 20. Okay, so now I can do the lower and upper quartile. So 1/4 of, well, there's 11 here, there's also 11 here, so 1/4 of 11 will give us 2.75, and 3/4 of 11 will give us 8.25. So the lower quartile is going to be the third number, so 13, because it's 2.75, and it would have gone past the second number. And then we've got the upper quartile, which is 8.25, so we've gone past 8, so it will be the ninth number, so that will be 19 here. Okay, so as I mentioned, the upper quartile take away the lower quartile will give us the range, so we can fill this in here. 19 take away 13 gives us 6, so the interquartile range is 6. Now Sunil did the same 11 maths test. The median mark Sunil scored in his test is 17. The interquartile range is 8. Which one of Sunil or James has the more consistent marks? Give a reason for your answer. So if we just look here, it says the median mark is 17 for Sunil. So let's just double check and see what James is. So if we have 11 data points, if I add 1 to it and then divide by 2 to find the median, that will be the 6th number when they're arranged in ascending order. So 1, 2, 3, 4, 5, 6. So James's median is 17, and Sunil's is 17 too. So the only difference between the two is Sunil has an interquartile range of 8, and James has an interquartile range of 6. So the question's asking what is or who has the more consistent results. So that would be James. And the reason why James has more consistent results is because the interquartile range is less, so there's less of a spread. So his results are more within a smaller range. So James results are within a smaller range, lower spread of results. Well, now we've got Sunil did 4 more maths tests. His scores in these 4 tests were 16, 20, 18 and 10. So if we just arrange that to 10, 16, 18 and 20. How does his new median mark for the 15 test compare with his median mark of the 17 for the 11 test? So he's got his previous test results, and now these results here being added into it. Okay, now rather than rewrite everything and add these in, what we can do is figure out the median of our new data. Okay, so if I've got 4 data inputs, I can either do the cross technique like that. So here I've got my 2 numbers, so what's in between 16 and 18? Well, that's 17. Okay, now let's just stick with that way for now. So if I just do the middle number between 16 and 18, which is of course 17, that means if his previous median was 17, and now these numbers are being added in and their median is 17, there's not going to be a change. So the new median will remain as 17. And explain your answer, so that the explanation for that could be that 2 scores were under the median, 2 scores were above. Okay, or the median of the 4 numbers, which is what we've done, is 17. So if the median previously was 17 and a new median for this small data set is 17, if you're going to merge them together, there's not going to be any change to the median. So no change to median, because the median of the 4 new tests is 17.2. Okay, this diagram shows a trapezium. All measurements are in centimeters and the area of a trapezium is 46 centimeters squared. So the area of a trapezium, we need to know that formula. Now this has come up in a previous practice paper, but it's come up again, so we should know how to tackle this question if you've been watching the videos. So if we've got area of a trapezium equals, we need to remember the song, half the sum of the parallel sides times the height between them. So that would be A equals half A plus B times the height. So of course we look at where our parallel sides are, doesn't matter which you label which. I'm going to go for this is A and this is B. We know the height is here and the area is given to us as 46. So our first part is show that, so they're giving us the answer and we need to show that, so we need to conclude or finish with that. So if I start on the left hand side now, so I write A equals half, and I'll put in what A is, so that's 5x plus 3, sorry, not times, plus 3x plus 1 times the height between them, so that's 2x plus 3. So now if I start with the brackets, so we've got half here, collect the like terms, so 8x plus 4 times 2x plus 3. Now I can use this fraction and get rid of it, so I could do a half of 8x will give me 4x and a half of 4 will give me plus 2. So if you remember from expanding brackets and the use of arrows, which gets me this part here. I can then put this in brackets like so, just to tidy it up. I can also substitute the area in, which is 46. So if I now take this over here, I've got 46, actually let me put it up here, so I've got 46 equals 4x plus 2, 2x plus 3. So we need to expand the double brackets so we can use FOIL. I'm not going to write it, but you can if you want. So then we're going to have 46 equals, first two terms multiply, so I have 8x squared. And the outside terms I'm going to have plus 12x. In the inside terms I'm going to have plus 4x. And the last two terms of each bracket plus 6. So if I now collect the like terms, I'm going to have 8x squared plus 16x plus 6. I need to make it equal to 0. So I'm going to take away 46 from both sides. 0 equals 8x squared plus 16x, and 6 take away 46 will give me minus 40. You can then see that there's going to be a highest common factor link between these three numbers, and that highest common factor is 8. So I'm going to have 0 equals 8 will go into 8 once, so 1x squared. 8 will go into 16 twice, so I'm going to have 2x, and 8 will go into minus 40 minus 5 times. And if we look at this versus this up here, you'll notice that they're exactly the same, because I can just do this. They both equal 0, so how it's written doesn't matter. For part B, solve the equation x squared plus 2x minus 5 equals 0. Give your solutions correct to 2 decimal places, which means we can use the formula. So from memory, the formula is minus b plus or minus the root of b squared minus 4ac all over 2a. So for solution 1, I'll have, first before we do that, let's say the value of A, the value of B, the value of C. Now this is going to come from the quadratic formula template, which is ax squared plus bx plus c. So if I compare this template with this, we need to fill in our values. So A is 1, B is plus 2, and C is negative 5. So now doing the first part, so the plus part first, I'm going to have minus the value of B, so minus 2 plus the root of b squared, which is 2 squared minus 4 times A times C all over 2 times A. And then for my second, I'm going to have minus 2, and this time minus the root of, and everything else is the same, b squared minus 4 times A times C all over 2A, which is 2 times 1. So these signs here are the only difference. So by doing that in the calculator, for the plus I get minus 1 plus root 6, which is plus 1.4494. So to 2 decimal places, that's going to be 1.45. So that's one solution. Now for the negative, I get minus 1 minus root 6. Pushing SD will give me negative 3.4494, which to 2 decimal places is going to be negative 3.45. Right, so question 7 is talking about surface area of the Earth and surface area of Jupiter. So Earth and Jupiter. So we're talking about surface area. Right, so we've got 510.072.000 km squared, and then we've got 6.21795 times 10 to the 10 km squared. So units are the same, so there's no conversion. It says the surface area of Jupiter is greater than the surface area of the Earth. How many times greater? So what we need to do is work out the scale factor. So how we can do that is, how do we go from Earth to Jupiter? Well, rather than doing like a trial and improvement way, we can do the opposite. So because the Earth is smaller, it would be times. So to go from Jupiter to Earth, we would divide. So what we can do is we can write 6.21795 times 10 to the 10. Divide that by that of the Earth, which is 510.072.000, and then we will get 121.90. Now it says give your answer in standard form. So this will be times 10 to the 0, 10 to the 1, and 10 to the 2. So we'll have 1.219 times 10 to the 2 as our final answer. Now there would have been no harm converting the Earth into standard form. So just to show that, if we have 510.072.000, remembering times 10 to the 0 will be here, 10 to the 1, 2, 3, 4, 5, 6, 7, 8. So therefore we'd have 5.10072 times 10 to the, and it's the one we started with, so 8. Okay. Now, if you just need to go over that, or you're not sure how to do that confidently, there are some videos on the channel which you can click and kind of go through those types of questions. And then you could have done this standard form. So you could have done the same thing, Jupiter divided by Earth, and you would have got 121.90. Given that in standard form, you then get the answer we got here, 1219, or 1.219 times 10 to the 2. Okay, so if we look at question 8, it's a circle theorem question. Now what I've done towards the right, obviously you can see the various circle theorems. Now obviously this is not there in your exam paper. I've just put it there because this will be easy to explain and to follow through. Now the circle theorems on the right you're going to need to remember from memory. You're going to be given a question like this question 8, where you're going to have to run through the various circle theorems and use them to your advantage. So we've got here QR, S and T are points in the circle. ATB is the tangent to the circle at T. Angle STR is 26 and angle RQT is 73. So we need to work out the angle STA, so S, T and A. So it's this angle here, okay? So by looking at this question, I immediately see that it's a cyclic quadrilateral. So that's this one up here. So if I'm looking and drawing this up, we can ignore the line R to T for now. If I join this up, you'll see it's a cyclic quadrilateral. Okay. Now the property about a cyclic quadrilateral is the opposites add up to 180 degrees. So by me spotting that, let's see if doing that actually gives us any help towards getting our final angle. So if we know the opposites add up to 180, I can find out the angle RST. Okay, so I can do 180 take away 73, which will give me 107. So this angle here would be 107 degrees. Now I can't do the other two opposites, because if we look here, I would need this angle here and this to match this angle here, or to find the angle there. Okay, but if you look, the 26 only represents a small part of this section. So I have to look at another circle theorem that I can use. Now take note that this line RT is not passing through the center point. So that means it will not be this circle theorem. We can't use this to work anything out. We also cannot use the first one, because again that's at the center point. We could then look at some of the other ones. Right, so having said that, we've managed to find out the angle RST is 107 degrees, which could mean from the properties of triangles that we could work out this angle here. So this would be, of course, 107 plus 26, which comes to 133, and then we would do 180 take away 133 to give us 47. And let's just show our working for that. 180 take away 107 take away 26. That would equal 47. So this angle up here is 47. So by working that out and looking at our circle theorems, obviously again this is going to be in your memory, but looking at our circle theorems, can we match anything up with what we know? Right, so by looking at this, if I can block this section out, just so that I can see this part of the triangle, okay? If I compare that now with the alternate segment theorem, okay? Now, this part here would be represented by this part here, and this part here represented by this part here. So if I look at that alternate segment theorem, what I can see is that this A, let me just change to the appropriate colour, this A here will give us this angle here. So we're not interested in the A, we want to find out this angle here, which happens to be the B. So if I look, this angle at the top happens to be this angle here. Well, that according to the alternate segment theorem, means that this angle here should be this angle here. Okay, now take note, if you look, the B represents the portion that we're exactly looking for. You can see that it does not go into the triangle. So therefore, by the alternate segment theorem, angle STA is 47 degrees. Okay, so these questions are going to take quite a while for you to digest. Obviously, it's going to depend heavily on your memory. So what I would strongly suggest is trying to practice as much as possible with circle theorems and try and memorize as much of these as possible. That way, when you're in an exam, you can cycle your way through it and see if you're able to get to a conclusion. Now, what you should remember is to always make sure you have a statement and reason, which here I haven't done. Okay, what you can do now is kind of add them in. So, for example, this RST, that was from the cyclic. Okay, we have this up here, which is angles, a triangle, and of course we have the alternate segment theorem listed here. Right, so question number 9. Sketch shows a curve with equation y equals ka to the x, where k and a are constants and a is greater than 0. The curve passes through points 1, 7 and 3, 1, 7, 5. Calculate the value of k and the value of a. So if we do y equals ka to the x, we know for one of the values x is 1 and y is 7. So let's do 7 equals ka to the 1. And for the second coordinate, the second point, we've got again y equals ka to the x. Then we have y of 175 equals ka to the 3. So we need to find both k and a. So I've got equation 1 and equation 2. Now what we can do is rearrange the first one for k equals and then substitute that in. So if we do 7 over a equals k, then we're going to put this equation here into this one here. So then we're going to have, if I follow it through up here, 175 equals 175 equals, instead of k, I'm going to put 7 over a, and that this here is from here. Okay, times a to the 3. Then we'd have 175 equals 7a to the 3 over a. And then of course these two would cancel out, so that would make this 7a squared. So then we'd have 175 equals 7a squared. Now we need to find a, so divide by 7 both sides, so 175 over 7 equals a squared. And then to get rid of the squared, we would square. So just to save space, the square root of that would give you a. So the square root of 175 over 7 gives us a value of 5. So from this we know that a equals 5. Then using either point, we can then write y equals kax. We now have a, so we need to find k. So let's just use this first point here. We got 7 equals k times a, which is 5, times x, which is 1. So we have 7 equals k times 5. Therefore k equals 7 over 5, and 7 over 5 is 1.4. So we have K is a value of 5 and A as 1.4. Right, so question 10. Work out the area of the triangle ABC. Give your answer correct to 3 significant figures. So the area of a triangle, we have area equals half times base times height. Now we don't have a height here, so we're going to have to use the other area of a triangle formula, which is area equals half AB sine C. So if we look at this, we've got A here, which means small a here, B here, which means small b here, and C, which means small c here. So if we look at this formula, we then substitute the values in. Area equals half times the value of A, 36 times the value of B, which is, we don't know, and times sine C, sine 48. So we now need to find B. So in order to do so, we need to use a sine rule. So we've got sine A over A equals sine B over B equals sine C over C. Okay, so we can use sine A over A and sine C over C. So I'd like to find angle A. So then if I rearrange this for sine A equals sine C over C times A. So therefore sine A equals sine of C, which is 48, over C, which is 57, times A, which is 36. So if I put that into a calculator, I then will have an angle A of 27.99. So let's call it 28. So if this angle here is 28 degrees, we know that angles in a triangle add up to 180. Therefore, this B angle will be 180 take away 48 take away 28, which is 104. So I'll just write the calculation there, 180 take away 48 take away 28. So now I can use B over sine B equals A over sine A, and therefore rearrange the B equals A over sine A times sine B. So running out of space, I can put B equals the value of A, which is 36 over sine 28 times sine of B, so sine of 104. Therefore B equals 74.40. Okay. Now I've got B, so I can find the areas. So down here, A equals half times 36 times 74.4 times sine 48. The area is therefore 995.219 to 3 significant figures. We look here, so it would be the area equals 995 3SF. This would of course be meters squared.